Hello, ladies and gentlemen. Welcome to Module 4, Inter-VLAN Routing. My name is Mr. Tandy. You can follow me at TandyIT, and let's get into this module right now. We're talking about Inter-VLAN Routing. So some of the things we're going to be talking about in this module, Inter-VLAN Routing Operations, we're going to describe the describe the options of configuring Inter-VLAN Routing. We're going to do a router on a stick. That's the demo I'm going to provide for you today. Inter-VLAN routing using layer 3 switches and troubleshooting inter-VLAN routing. So before we get into the next part, I want to show you this video again, okay? Now, I showed you this video in my third video, Module 3, okay? We watched this video, and I want you to see this video again, and we're going to change a couple things up with this video. Okay, so if you remember in this video, we talked about we have the egress coming in. We talked about this big factory being a big, huge switch, right? This is a big switch. All of these packets that are coming in, and when those packets come in, a layer 2 switch is designed to develop a MAC address table, which we said maybe this device here in the middle is scanning all of this things coming off of the trucks, so it knows where to divert it afterwards. So it knows the MAC address table is building a MAC address table, doing all that good stuff. So as it gets scans, as it knows exactly where it needs to go, it essentially just gets routed to the correct port on the switch, right? It gets routed the way it needs to go. So if you remember this video, this is what we talked about. Now, I'm going to go back here really quick. Go back a couple little frames here, because we're talking about VLANs, okay? We're talking about VLANs. Let me find this thing here. Where is it at? All right, so we're talking about VLANs. Take a look at this picture. Because in order for different subnets to talk to each other, you have to have a router, right? Or you can have a multi-layer switch. What I want you to think of is this multi-layer switch, which has layer 3 capabilities because it's layer 3, right? Network stuff. I want you to think that each one of these bays is attached to a specific VLAN, right? A virtual local area network. All right, so if we've established that these bays are attached to different VLANs, okay, different VLANs, and that means this action that's going on in here in the middle must be inter-VLAN routing. Okay, let me explain that again. Inter-VLAN routing, and there it is in action. There is the inter-VLAN routing, right? So all of these packets that are coming in off these different VLANs, okay, they get scanned, right? They get scanned. Oh, and by the way, we are going to get into this in here, after this part gets scanned, is essentially like the trunk of the switch, right? Where the trunk goes out, because it needs to be able to go, it needs to be able to know where it needs to go, right? Once it hits the switch or the multi-layer switch, it's got to have a gateway in order to get to the next VLAN. It's got to have that, right? So that's kind of similar to what this is here. But again, I want you to think of this whole company here, this big building here, as a multi-layer switch. One big router. Switch everything all in one, right? All the packets come in on these different VLANs, and the packages, when they come in through those little egress ports, they go out and they start going off into the different VLANs. And there's the inter-VLAN routing right here for this multi-layer switch. So I want you to see that, because as we get into this, I just want you to kind of have that frame of mind when it comes to inter-VLAN routing. Okay, so let's get into this here. Inter-VLAN routing operations. All right, so VLANs are used to segment switch layer 2 networks for a variety of reasons, right? Regardless of the reasons, hosts in one VLAN cannot communicate with hosts on another VLAN. They just cannot talk to each other. unless there is a router or a layer 3 switch provided for routing services. So like that video we just saw, that was like a multi-layer switch, right? Inter-VLAN routing is a process of forwarding network traffic from one VLAN to another, to other VLANs. There are 3 inter-VLAN routing options. We have legacy inter-VLAN routing. This is a legacy solution. Doesn't scale all that great. Router on a stick. That's the demo I'm going to show you for today in this video. And the layer 3 switch using switch virtual interfaces. Okay, switch virtual interfaces. Now, the first type of inter-VLAN routing is a legacy, right? This is the first inter-VLAN routing solution relied on using router with multi-Ethernet interfaces. So essentially, it's like taking a router, right? A router that has multiple ports to them, and essentially making those 2 ports accessible to different gateways into a switch, right? And each one of those cables represents essentially a virtual network, right? Configuring those, you would have to trunk those. Essentially, it's kind of like this, right? You have 2 connections coming out of the router, and both of these would be trunked into the switch in the trunk here. This is the old school way, right? Legacy inter-VLAN routing using physical interfaces, but it has significant limitations and is not reasonably scalable because routers have a limited number of physical interfaces. Yeah, so you can't really do this. I mean, you can if you have a small network, but big enterprise networks, not doing this, right? You're probably going to do it a different way. Router on a stick, this is what I'll be showing you on the demo. Router on a stick is an inter-VLAN routing method that overcomes limitations of the legacy inter-VLAN routing method. It only requires one physical Ethernet interface, right? So you just only need one cable. I want you to think of that cable as a street, right, or a tunnel. I want you to think of that interface as a tunnel, okay? We're going to go back to that. Think of that as a tunnel. So the router interface is configured using sub-interfaces to identify routing VLANs. So I want you to think of that tunnel, and there's like many tunnels inside the one tunnel. The configured sub-interfaces are software-based virtual interfaces, each associated with a single physical Ethernet interface. Okay, so the sub-interfaces are configured in software on a router. Each sub-interface is independently configured. So each one of those interfaces, you'll see when we do the demo, you have to configure each one of them. Each one of them is going to need a gateway. So let's talk about protocols. When VLAN traffic is tagged, when VLAN tag traffic enters the router interface, it is forwarded to the VLAN sub-interface after a routing decision is made based on the destination IP address. Remember that mail truck. Mail truck comes in, brings in your mail. That's the source. It's putting that mail inside that little switch, right? That little mailbox. That's the destination IP address, okay? So it does come with a protocol, and that protocol is 802.1q. That's the sub-interface. That's the protocol to enable essentially the encapsulation on a router on a stick. Inter-VLAN routing on a layer 3 switch. Okay, that's a multi-layer switch. A modern method of performing inter-VLAN routing is to use a layer 3 switch virtual network, right? So this individual switch virtual networks inside this layer 3 switch. It has layer 3 capabilities. Therefore, we're going to be using IP addressing, right? A layer 3 switch is also called a multi-layer switch as it operates on layer 2 and layer 3. However, in this course, we'll use them as a layer 3 switch. All right, so inter-VLAN routing continue. Inter-VLAN SVIs are created the same way that a management VLAN switch is configured. So the way you configure those switch ports, right? They're all the same. Switch port mode, access, switch port mode, all that good stuff, right? The SVIs are created for VLANs that exist on the switch. Although virtual, the SVIs perform the same functions for the VLANs as a router interface would. So especially it provides layer 3 processing the packets that are sent to and from all switch ports associating with the VLAN. All right, so they do a lot of layer 3. The following are advantages. So you got to there's some advantages, all right? This is good to have this. Things are much faster. Okay, if you think about the CIA triad, send me an email. Here's a code word, CIA triad. And I also want you to send me an email. Let me know something that makes things much faster. What is that effect of the CIA triad? Let me know. Send me an email on that, please. There's no need for external links for the switch to the router the router for routing. They're not limited to one link because layer 2 Ether channels, we'll be talking about that later, can be used to trunk links between switches to increase the bandwidth. All right, so we want to make things go a lot faster. The only disadvantage is that layer 3 switches are more expensive, so they are pretty, they cost a lot of money. More than likely, you won't see any layer 3 switches in my house. Okay, not happening. All right, so router on a stick. Router on a stick scenario, okay, in this figure, and let me show you how this works. So essentially, if you see this, we have a switch network here. We have two switches that are trunked together. And as you can see, both of these are on two different VLANs. We have VLAN 10 and VLAN 20. Let me remove myself out of the way so you can see. So we have VLAN 20 and VLAN 10, right? I want you to take note of the gateways. So these gateways are configured. Here's a gateway at 192.168.10.1 and then 192.168.20.1. So they have two different gateways. So these are on two different networks. If you look at the WAC 24, the first 24 bits are on. That means the first 3 octets cannot change. You can see that these are on different networks. We have this trunk in between the two switches, like we did in earlier videos. And now they added a trunk link to the router, because the router this is what's going to route to the different VLANs. So to route between VLANs, router 1 gigabit Ethernet logically divided into 3 sub-interfaces. So essentially, this cable right here is going to get divvied up into essentially 3 little ones inside, 3 little cables inside of them, inside of one big cable, right? So assume that router 1, S1, and switch 2 have the initial basic configurations. Currently, PC1 cannot ping each other, right? So these two cannot ping each other at all. But when you have the router on a stick configured, that Marco Polo can go through the router, come through the switch, and get to its destination that it needs to. Okay, so before we get into router on a stick and the demo, I wanted to kind of paint the picture of what we're getting ready to do here, okay? So I just took a picture, just ran a picture off the internet. So this is a picture of a tunnel. And what I want you to think of this tunnel as a big Ethernet cable. Okay, this is a big cable. On one end of the tunnel, we have our router. So we just call that's actually really, really bad. Let me change the colors on that so you can see that better. Sorry about that. On this side of the tunnel, we have our router, okay? And on this side here, we're gonna put an S. This will be the switch, all the way on the other end there, okay? This is a switch. Now, this is an Ethernet cable. It is plugged in, and it is plugged into the router and into the switch. You see we have a very, very long connection here. All right. At this point in time, we're just going to say that this cable is trunked. Okay? This cable is trunked. And as we know with trunking, put everything in the trunk. We're all going on a vacation. It handles all of the VLANs like it needs to. We're all good to go. But here's the thing. When we configure the router on the stick, we're going to basically take this trunk, okay? Now we're on the router side. We are going to, and I'm going to change the color here, we're actually going to take the trunk and we're going to divide up the cable. So just imagine you entering into this interface, okay? And you have one cable, but you see it as 3 different cables inside of one. So let's say, for example, here, since we divided this up, we have our native VLAN. We'll call this VLAN 99. This will be our VLAN 20. Remember, that was our sales department. And here we have VLAN 10. Okay? So here it is, a good example. I took the tunnel, divided up into sub-interfaces using one cable. Okay, so let's take a look at this demo here. We're going to do a router on a stick. this particular demo may look a little familiar from Module 3's video, so it is a little different. But what I did was I went on ahead and added another switch. And what we did was we applied a trunk to this area, right? The trunk, this is the trunk that carries all the VLANs. So we had to configure this port. We had to configure this port on the switch. I added 2 more PCs and put them on different VLANs. So we're able to extend the network here with another switch, as you can see here, okay? So before we begin, what I'm going to do is I'm going to change some of the configurations on our end devices here, okay? It's not going to be very huge. It's just very simple. So follow along here. What I'm going to do is I'm going to take all machines that are on VLAN 10, okay? I am going to change the third octet to the number 10. However, actually, let me do this first. So let's just change all this to 10. That's VLAN 10. Here's another VLAN 10 computer. So I'm switching all of these to 10. Yes, we are going to go into the configurations and actually change the IP information. We are. Uh-oh, this thing is yelling at me. But I just want to do this first because it's a lot easier to reference when you see it this way when we're doing pinging and things of that nature. Okay. Now, anything that's on VLAN 20, we're going to change the third octet to 20. So let's go in here and do that now. So this is the third octet. We're going to call this 20. This is also VLAN 20. We're going to call the third octet 20. And we have our server machine here. We're going to change this to 20 as well. Okay. And we have VLAN 20 again with this PC5 machine. We're going to change this to VLAN 20. All right. Now, let's go in here and change the IP information now. Now that we have it all in the visual here, let's go ahead and change the information now. So let's go into the PC, this first PC, PC10. We're going to rename the PC with the correct IP configurations. Okay, so we're going to go 192.168.10. Okay, now just for this one, for this computer only, please pay attention. I'm going to switch this to a .2. And I'm going to give this computer a gateway of 192.168.10.1. So please note, every computer that is on the 192.168.10 network, which will be the VLAN 10, is going to have this gateway. The gateway is going to be 192.168.10.1. The only reason why I'm changing this one to 2 is because we're going to reserve 1 for our gateway. So now this machine now is 192.168.10.2. Now just for the heck of it, I'm going to go over here and I'm just going to change this to a 2. Okay? I'm going to change this to a 2. All right. Let's go into all the VLAN 10 machines and change those up. Desktop here, we are on PC3. We're going to leave all this the same, except we're going to change the third octet. And then what did we say our gateway is? It should be 192.168.10.1. And I apologize. This is supposed to be a 10. All right. So there we go. We have that set. Let's find another VLAN 10 computer. Here we go right here. We're going to go into that computer. And we're going to switch this to a .10.6. And what is our gateway again? 192.168.10.1. That is our gateway. That is our gateway. That is our gateway. Okay. And I think that's good for VLAN 10s. Now let's go back into the VLAN 20 machines. Now this is where things are going to be different here. And this is all going to make sense here in a minute. All right, so we have VLAN 20. We're going to change this to .20, and we're going to give this an IP address for the gateway 192.168.20.1. Okay, .20.1. So every machine on the sales VLAN, okay, is going to have a gateway of 192.168.20.1. So let's go ahead and do those right now. We have another 20 machine here. Go to desktop. Okay, we are going to change that to a 20, and we're going to give this a 192.168.20.1. That's our gateway. That's our gateway. Let's go into this machine here. This is 192.168.20.5. We're going to reconfigure this one as well. We're going to change the third octet to a .20. And we're going to give it the IP address for the gateway, 192.168.20.1 again. Okay. And let's go into the sales machine, the server, excuse me. And as you can see in the server, this is going to be a .20.7. So we're going to switch this to a .20. And we're going to give this a gateway of 192.168.20.1. Okay. So what we did here, essentially, we changed the gateways. We added gateways to the computers, but we changed the IP addresses too, just with the third octet. We were messing with the third octet. Notice how VLAN 20, they all have the third octet of .20, WAC 24, third octet .20, third octet is .20. So all these are on the same network, right? So they're all still going to work the same because they're on the same subnet. They're on the same network, same subnet network. So let's just check for verification purposes. We're going to go into the .10 computer, no, the 10.2 computer. And what we're going to do is we're going to ping this .6 computer down here. Let's just make sure it works. We're going to go ping. Uh-oh, not poing. Ping 192.168.10.6. Let's see if we get some replies. And as you can see, we are getting the Marco Polos that we need. So we just pinged this computer here. And this is telling us that the VLANs are working inside of the switches like they're supposed to be, even with the subnets staying the same. But we changed the octet in the 20s. That's all. And we added a gateway as well. Okay. So now what we need to do is add this router. Okay. So we've got everything configured. We've got the gateways configured on all of our end devices. They're all on the different VLANs. We pinged them. Everything is still working, but we still can't ping other VLANs, right? That's because we still need a router. So let's go in here. We're going to select the P28200 router here. Oops. Okay. And let's go ahead and add a copper cable here, copper straight through cable. Please take note which cable you're plugging this into. We're going to use 3/1, and for the switch side, and on the router side, it's going to be triple zeros. Gigabit Ethernet 00000. All right. So let's go into the router really quick, and let's just type in boot so we can get everything up and running, so we can kind of see some good lights, see if we get some good connectivity and all that good stuff. Okay, so if you remember from our other videos, we had the trunk, right? We had the trunk in between the different switches. We had to trunk these ports. Hey, we had to get everything in the back of the trunk, so we're going on a trip, right? So we are going to have to trunk this port. This is 3-1. 3-1 needs to be trunked. As you can see here, it is down right now. That's because the router's not up yet. However, we are going to have to trunk this port. We got to get this port trunked. So let's do that. Let's go into PC, and we're going to go into the terminal. All right, let's see here. Let's type in config T. Actually, before we do that, I want you to see something really quick. Let me go in to the switch so you can see this. And password Cisco. Okay. I'm going to type in the show interface trunk command. See, I typed in show interfaces trunk. As you can see, we only have one trunk here, right? That's the 2.1 trunk, 2-1. We've got a trunk 3-1, 3/1, right? So let's go ahead and do that. So we're going to go config T. Config T. Interface fast Ethernet 3-1. And if you remember what I like to do in my other videos, I always like to shut it down. That way I can just see it turned off. That way I know 100% sure I'm working with the correct cable. That's just me. That's just how I do things. So bear with me on that. So we're going to go no shut. We've got to turn that thing back on. All right. So now we need to configure the trunk. We need to trunk the ports, right? We need to get a trunk. So let's go switch port trunk. Okay. We're going to go switch port trunk. I'm sorry. We're going to go switch port mode. Apologize. Switch port mode. Sorry, my fingers are all over the place. Trunk. Okay. Now we're trunking the port. Okay. Let's start with our native VLANs now. Our native VLAN is VLAN 99. So we're going to go switch port trunk native VLAN 99. Okay. Now we need to go switch port trunk allowed. Okay. Now we got to allow all the rest of the VLANs in. So it's going to be 10, 20, and 99. And we're going to type in no shut. We're going to exit. And we're going to end it. And then we're going to write memory. There we go. So now we have our trunk taken care of. So let's verify that. Let's just make sure that we are good to go here. Show interfaces trunk. And as you can see, 3/1 is properly trunk and the mode is on. So I've told both of these sides to be on, right? 2-1 is on, this side is on, and this one's on. That's the mode I gave it. I didn't give it dynamic or desirable. I just said, hey, you are going to turn on. Okay, so great. Now we have our trunking done, which is absolutely awesome. Now, let's get into the router. All right, so let's get all the initial configurations done. You should know this really quick. I am going to go config T, line console 0, password, class, log in, okay, end, end. And then we're going to enable secret. I'm sorry, I got to be in config after that. Apologize. Enable secret, and we're going to give that the password of Cisco. All right. Let's change the host name. Let's go host name. Host name. Let's go router 1, maybe. Let's call it router 1. We'll just call it R1. Nothing big. All right. And that's it. Okay. So let's just verify everything's working. Class, enable secret, and it's Cisco. All right. Very good. Okay. So in order for this to work, if you remember from the videos, and earlier in this video, we talked about data encapsulations, right? It is important that we have to encapsulate that data through this trunk. Now, we already have a trunk. This trunk is going to work. But on this on this router, I apologize. On this router, using this one interface, what we're going to do is we're going to create sub-interfaces inside that one interface. So essentially, it's like going down a big tunnel, and you have one big singular tunnel. In that tunnel, you're going to put up 2 big dividers inside that same tunnel, using that same infrastructure inside that same tunnel. And each one of those dividers, or those sub those sub areas, okay, are going to be gateways to different VLANs. Those are going to be roads to the different VLANs. So that's what we're going to configure on this router. All right. Okay, so let's go into this, to the router here. We're going to do this all over here again, class and Cisco. All right, so let's take a look and see what we have here. We're going to go show interfaces trunk. As you can see here, I typed in the trunk command. There's nothing trunked, right, in the router. No big deal, right? We're going to go show interfaces. Excuse me. We're going to go show IP interface brief. And as you can see here, there is nothing assigned here to 0/0/0/0, right? That's the Ethernet connection we are worried about right now. That's the one that's connected to the switch from the router. Excuse me, it's connected to the router from the switch. Apologize, from the switch, right? Okay, so let's access that Ethernet cable. So we're going to go config T, interface, gigabit Ethernet 0/0/0. I do realize you can do it a shorter way. This is just the way I like to do it. Okay. Again, I want to make sure that I'm working with the correct one. I want to type in shut down. That tells me, we see the red there, everything is shut down. Now I know that we're working with the correct one, so I'm going to type in no shut. Let's get that thing back up and running. Okay, now we're working with the correct interface. All right. So now what I want to do, we already typed in no shut, right? So we're good. We have no shutdown. That thing is up and running. Now, we're going to type in interface. Actually, let's back out. I'm sorry. We need to go out one more. Okay. Interface, gigabit. This is where we're going to create the sub Ethernet cables, right? The sub interfaces, right? So we're going to go 0/0/0, and then we're going to go .10. Okay? .10. Okay? Now we're going to do encapsulate. There is that protocol, DOT1Q, and we're going to encapsulate everything in the VLAN, the top 10 in the VLAN, the admin VLAN, right? There it is right there. So we got that one done. We're not done yet. What do we say the IP address is going to be for the gateway? That is correct. So we're going to go IP address 192.168.10.1 with a 255.255.255.0. Enter. Very good. So now that we have that complete, now we need to get into the other interface, right? We need to stick with the same interface, but we have to create another lane in that tunnel, right? Another lane in that tunnel. So we're going to go exit, okay? And now we're going to type in, let's see here, it was interface gigabit. Now we're going to go 0. Okay, we're going to go 0/0/0.20. Now there's another sub interface, right, with .20. Okay. What do we need to do? We need to get it encapsulation data, right? We need to encapsulate it. And we're going to give that an encapsulation of 20 because that is VLAN 20. So that's going to carry all the VLAN 20 traffic, right? And IP address of 192.168.20. And the reason why it's 20 is because we're dealing with VLAN 20, which is the sales department, all VLAN 20, okay? Okay, .1. And then we have a subnet of 255.255.255.0. All right, we're almost done. We're almost done because now we still need to configure the native, right? We need to configure the native in that sub interface. So let's go exit here. Okay. Now we're going to give the native, it's going to be interface gigabit Ethernet 0/0/0 dot, and guess what, folks? 99, right? 99, because we have VLAN 99. That's our native VLAN, right? So we're going to press enter. That's going to be up and running. Now we need to give that an encapsulation, right? So let's encapsulate it. There's a protocol for that. 99. Okay. 99. And now let's give it an IP address of 192.168. We're just going to call this one .99.1. Okay. And the subnet mask 255.255.255.0. So everything is there. All right. Let's take a look and see what we have here. So let's go to config T. Actually, let's do this. We're going to go show IP interface brief. And as you can see here, we now have our sub interfaces already set on Ethernet 0. Ethernet 0/0/0/0/0. Okay. There's our IP addresses. They are set. So we're ready to go. All right. One thing we got to do, let's go in here and write to memory. We're going to go write memory. Though everything is all running, everything's all ready to go. All right. So since everything's good, we should be able to ping, right? Let's test it. Okay, so let's start with the router. Let's ping out from the router. Let's see if we can reach the devices on both VLANs from the router. So what I'm going to do from the router, just to start things off, I am going to ping this machine here, which is .20.2. Okay, this is on the VLAN 20. This is sales computer 192.168.20.2. So let's do that one. So we go ping 192.168.20.2. I'm not going to run a simulation. Let's just see what we get. Let me run it again because we got 80%. As you can see now, we have 100% success rate, right? Now, let's ping the other machine that is on the .10 network, right? This is VLAN 10. Let's do that one. So I'm just going to hit the up arrow here and change the numbers here. 192.168.10.2. And as you can see, we have 100% success rate on that one as well. So that tells me that this router is carrying the data. It has both of those lanes in that big tunnel. It's all set, right? Those subcategories, those sub lanes in that big tunnel is all ready to go. So everything should move right through here. All right, so let's test that and let's run the simulation on one of them. So what I want to do is let's go into the sales machine, the server computer down at the bottom. And what we're going to do, let's go into the desktop. Let me turn on my simulation so we can actually see this, okay? So what I'm going to do is I am going to ping, the sales machine is in VLAN 20. I'm going to ping another machine that's in a different VLAN. So let's see if we can ping this machine up here, which is on VLAN 10. So let's do it. We're going to go 192.168.10.2. Okay, 10.2. Uh-oh. Let's put this up here. All right. Uh-oh. Forgot to add the ping, folks. It would be better. It would be nice if I actually add the ping command to that. Okay. As you can see, the packet is starting here. Let's advance it. It's going down to the switch. Switch already has a MAC address table already set up, ready to go. So it knows it needs to go out. There we go. It's going over to this network. It realizes that this is not this machine. So it did ARP. As you can see here, it ARPed. It said, hey, who has? If you look at the destination IP, it says who has 192.168.10.2. This computer basically said, that's not me. So another packet got sent to the switch, which went to the other network. So it went through the trunk. Let's continue out. It did it again, right? So it knows that this is not my information. Now watch the packet, folks. It's already at the third switch. Let's see where it goes. These machines said no. Yeah, I was going to hit the router. There's our egress. It comes right back out. Now it actually goes back again. Let's keep following it. Remember, we're trying to get to the .10, the 10.2 machine. There it is. It finally reached the computer. Goes back to the router, back down to the switch. There's the first one. As you can see now, everything's kind of turning into a unicast now. It knows where it needs to go through the router, back to the router, through the switch, back to the machine, back down to the switch again, back through the router, through the gateway, back to the switch, to another switch to the machine again, and we're going back, and so on. Okay, so let's run it in real time so you can see it. And there it is. It's finished. So that is routing, or a router on a stick. All right, this concludes Module 4, Inter-VLAN Routings. We'll see you on the next video.